Okay. So I put this question number 2, reactants to products, on here because of even I still mess it up sometimes. I'll say products when I mean reactants for no real reason. It just happens. So, what does it mean for a chemical equation to be balanced? So each element has the same number of atoms present on both sides. Both sides. Oop. And by both sides, I mean the reactant and the product side. So, oh, what the heck? What does that even say? To balance an equation, you can manipulate, Jesus. You can manipulate the coefficients, the subscripts, both or neither. Coefficients. Why can't you manipulate the subscripts? Yes. Because if you have water, H2O, and you try and balance it by making it H2O2, that's bad. It's not the same thing anymore. When ionic compounds dissolve in water, they may separate, yes. What's the sciencey term? Not dilute. Not decompose. That's a type of reaction. But what you said, separate, that is like correct, but I want a specific word for it. Not dissolve. I mean, it does dissolve, but so it can dissolve and still stay in like its compound form. But if the two ions separate, no. So, okay, go back to that thought. In lab, when you use water, what type of water do you use? Deionized water. So if you have ions in your water that are separate, so like if you have sodium ions and chloride ions, but you don't have sodium chloride, what did they do? You're not wrong. It is okay. They're gonna dissociate from each other. No, it's not. Yeah, it's just the sciencey word for it. What are the two types of reactions that we talked about on Thursday? Did we talk about synthesis and decomp? Yeah, what were like the two really big ones? Yeah, oh, freak, that's why. I have metathesis on my key. So you said synthesis and my brain was like, nope. But yeah, no, you're right. That's one of them. So the second one that I have down, I'll go ahead and put synthesis. The second one that I have down, it is not decomposition. It's not, yes. Huh? No. So, yes, precipitate. And it's different in that it's a type of metathesis, right? I want to say yes, because I can't think of anything else that would be one, yeah. What is a precipitate? What does this mean? What's a precipitation reaction? When a solid forms, right? But, okay, what you guys were saying, I just focused in on these two. This was a bad question on my part, I'm sorry. But redox, combustion, decomp, those are all types of reactions. Like, you guys are not wrong. It just wasn't what I was looking for, and I should have worded it better. Which polyatomic ions are always soluble? Nitrates are always soluble. And ammonium. What's the formula for nitrate? And for ammonium? These two are always soluble. So what if they're paired with each other? They're soluble. Yeah, it's a trick question. Because they're fun sometimes, I won't lie. Okay. So now we're going to do some balancing. Woo! Okay, so what I like to do is I like to just kind of draw a line down the center, and I set up and like put all of the elements that there are. For things like this, you can put the polyatomic ions together. And I make sure they're all the same on both sides, like in the same order. You don't have to do that. It's just what helps my brain concentrate. Okay, what element do you guys want to start with? Iron? Okay. We have 2 here and 1 here, so what has to happen? Oh, shoot. Sorry. I start off by listing all of the numbers. So iron, how are we going to make this 1 a 2? We're going to give it a coefficient of 2. I really recommend working in pencil when you do these, or like just giving yourself enough room to scratch numbers out. They can get kind of messy sometimes. So now we have 2. Okay. But this also means we now have 6 of the Br, right? Put a 6 on the right side. So now we have 6 Br. And we have 6 hydrogen. So now what? 3 on the left side. And now we have 6 hydrogen, 3 sulfates, and it all matches, right? So what's the ratio for this if you were just doing coefficients? Yeah, just the ratio. Because a lot of times on tests, she'll give you just the ratios, and you'll have to pick which one's right. Like just the ratios as answer choices. So this next one, number 9, big numbers And I put this in here because big numbers tend to scare students, and I know because I am that student. Whenever something is too big, I think it's wrong because it just seems so unfeasible. So we're going to get some big numbers in this one. So we have H, Si, Cl, O. And we have the same things over here. So we have 3 hydrogens, 1 silicone, 3 chlorine, 1 oxygen. Here we have 11, 10, 15, ooh. Oh.
16.
Yeah, what on earth?
You just make it HClO.
Let's just put O over here on its own, on its very own. Because apparently I was just typing too fast or something. I'm just going to keep it on its own. This really is not correct. What should it be if this were real?
It'd be paired with something else.
If it were on its own? O2.
Oh, yeah.
Because it's diatomic, but I totally screwed up. So it's not going to be. But this isn't real. Okay. Yes. Thanks. Okay. What do you want to start with? Hydrogen?
Wait, is that hydrogen only one?
There's 3 because there's the 2 here and then 1 here. Yeah. You're good. I'm going to not start with hydrogen, but here's why. I tend to kind of look and see what's going to be the easiest to balance first. And so I'm going to start with silicone because 10 to 1 is a pretty easy ratio to manage. So how am I going to make this one a 10? Put a 10 here. So now I have 10 silicone. I now have 12 hydrogen. And, 30 chlorine. Okay. What do we want to do next?
We can do chlorine.
Chlorine? I feel like I made a typo. I feel like this is supposed.
Like Cl14 and Cl. That gives us like an even number. We multiply all that out.
Wait, I'm sorry. What'd you say?
I said shouldn't it be like Cl14 or something? And then the other one would be make it 15. You can multiply it by 2, and then get 30, and then balance out right there.
Oh, shoot. I'm so sorry. I feel like this happens every session. I just pulled this question off the internet because that seemed easiest, but that's my own fault, man. Because what I have is 10, 15, 1, 30. And I just, you know what? Nope. Yeah. I think this is supposed to be the O. Because that makes sense. Right? Does that make sense to you guys? Does that look like it'll work out? Because it looks like it'll work out to me. Yes. Yeah. Okay. So let's do oxygen next. 15 and 1 is also a pretty standard ratio to manage. And so that 15 is going to go here. So now we have 15 oxygen here. And so now we have 30 hydrogens here plus 10, 40 hydrogens. And so what element do you guys think we should do next? Which one has the easiest? Yeah. 30 here. So now we're going to have 30 chlorines here. Now we have 30 hydrogens plus 10 hydrogens is 40. And that's how that worked out. Yeah, so that was my bad. I made a typo and I will go in and edit the one on my website. I'm so sorry about that. Okay, these I know are right. So predict the solubility for NH42SO3. What's the name of this? Ammonium what? Sulfite.
How do you know?
Because of this 3 right here. When it's 4, it's sulfate. So is this soluble or insoluble? Soluble. What's the name of this? Calcium sulfate. Is it soluble or insoluble? Insoluble. You'll have to look at that flow chart, and it'll tell you, the more you work with it, the more you'll learn it. Honestly, I just recommend practicing and figuring things, like doing like flashcards or like a Quizlet or something like that. Because personally, remembering solubility was like my weakest point. It's just a lot to remember sometimes, so. Okay. I'm gonna do the quizzes thing. Okay. What do you guys want to do first, solubility or balancing reactions? Balancing? Okay. What do I want to do? Okay, cool. Continue. Okay, this is the thing. I have music. Oh my god. That was so much harder than I expected it to be. Okay, so we should have like 9 people. Oh, see here? No. Okay. I've never used this for like actual content. I've only used it for like a warm up before, so we'll see how this goes. Oh. Wow. Okay. Hey, Zoom. Okay, cool. Can you guys hear me now? I turned my mic back off for a bit while that was going on. I actually can't pull up the chat right now, so I hope you can hear me. So I'm going to go over the 2 most missed questions. And then we'll be done for today. Okay, cool. Stop sharing, go back. Hello. Okay, cool. So this is the first most missed one. H2O2 decomposes to H2O and O2. Okay. So we're only working with 2 elements, H and O. We have 2 hydrogens here, 2 oxygens. Here we have 2 hydrogens and 3 oxygens. So I'm going to tell you the only trick that I know. I know she gave you one for combustion reactions and like oxygen division, whatever. I don't know that one, so I'll try and look it up so that way I can bring it up. But the only trick I know is that whenever you see a 2 and a 3, you're going to want to make it equal 6. So you're going to want to multiply this one by 3 and this one by 2. We're going to have to figure out which one we want to do that to, though, because there's 2 oxygens here. That's where things get messy when the same element is in 2 different places. So now we have 6 oxygens and 6 hydrogens. Whew, okay. So part of this, kind of like the worst part of the balancing equations, is there's a lot of like trial and error and just kind of guessing and seeing what happens. So let's balance out the hydrogen first. Let's do, so if we want to balance the hydrogen, what would we put here? 3. So now we're going to have 6. Now we have 3 oxygens plus 2 oxygens, that's 5. Oh, yikes. Okay. So now I'm going to tell you the only other secret that I know. And that is when you keep going back and forth like this and you just can't seem to get it right, start from scratch. Erase everything. And put a 2 in front. Put a 2 at the very front of the equation. That gives us 4 hydrogens, 4 oxygens. Oh, shoot. And everything else is the same. 2, 3. So now what do you guys want to start with? Which ratio is easiest to work with? Hydrogen. So how are we going to balance the hydrogen? 2. That's going to give us 4 here. That's going to give us 2 oxygens here, 2 here. So we have 4. And so that's what I was saying earlier. Like if you feel like you can't make it work, just put a 2 in front and then see where it takes you. Because sometimes it works. And like there really is no secret to knowing when you need to put a 2 in front. It's just like if you keep going back and forth and it's not balancing and you're getting frustrated, just go ahead and do that and then see if it works for you. Okay, and then the second most missed question was this. That's glucose, right? C6H12O6. Glucose and oxygen turn into hydrogen and carbon dioxide. Hydrogen, I said hydrogen and carbon dioxide. I definitely meant water and carbon dioxide. Whoops. Okay. So we have C, we have H, and we have O, and that's all we have here. We have 6 carbons, 12 hydrogens. Here we have 8 oxygens because we have the 6 here and then the 2 here. Here we have 1 carbon, 2 hydrogens, 3 oxygens. Where do you guys want to start? There's 2 fairly simple ratios that we can work with here. Whichever one you want to start with is fine. Hydrogen? Okay. So we have 12 and 6. How are we going to balance that? Or, we have 12 and 2. How are we going to balance that? So 6. So we have 12 here now, and we have 6 here. So our carbon and hydrogen are balanced. Our oxygen is not. Oh, that's a lie. Because now we have 6 oxygens here. And wait. Shoot, sorry. I was acting like my oxygen was carbon. That is totally my bad. So we have 6 oxygens here, 2 here. That's going to give us 8. So now our hydrogens and oxygens are balanced. And our carbon is not. How are we going to balance the carbon? Oh, shoot. Oh, my gosh. What's wrong? What's wrong with the hydrogen here? Is it?
I got
No, that's right. I'm sorry. I'm on another planet right now. Okay. So what are we going to do with the carbon? 6. So now we have 6 carbon here, but what happens to our oxygen? We have 12 oxygen. So over here we have 8. We have oxygen in 2 places. We need 12. How are we going to do that?
Wait, isn't it more than 12? Like 18?
multiply oxygen by 6.
Oh, yeah, shoot. You're right. You said that there was more than 12. Oh my gosh. I'm sorry, guys. This is like a little embarrassing. We have this 2 here. Thank you for calling me out. 18 oxygens. Perfect. So now that you have oxygen in 2 places. You have 2 places to choose to put numbers in front of. So what I really want to point out here is that since you have carbon and hydrogen already balanced, you only need to fix oxygen. Only mess with the lone oxygen, because if you put anything here, you're going to mess these numbers up, right? What should we put here? 6? Yes. And now that's 18. What's our ratio? Yes. And that's that equation solved. So those were the 2 most missed on the quizzes. That's all I have for you guys today. Hopefully we get to do more solubility stuff next time. I really hate it, and some of you guys probably hate it too, but that's okay, because we're going to get through it. It's all going to be great. Okay, I'll see you guys in class tomorrow.